Welcome to MRL. This is the second part of learning of circles, and in this part we'll be learning about the different types of tangents and their properties, and also the other properties of circles. So now the different types of tangents are: we have the tangent to a circle at a point on it, and the tangents to a circle from an exterior point, and the common tangents. Now let us go one by one. The tangent to a circle at a point on it. Now we have a circle here. The point P is this point P is a point on the circle, and APB is the tangent. Only one tangent can be drawn to a circle through a point on the circle. P is a point on the circle, APB is a tangent to the circle at point P, and P is known as the point of contact. Now tangents to a circle from an exterior point. The two tangents can be drawn to a circle from an exterior point. Now here the exterior point is P. We have a circle here. The P is the exterior point. PA and PB are the two tangents which are drawn to the circle from an exterior point. The two tangents drawn are equal in length, that is PA is equal to PB. They are equally inclined, that means angle APO is equal to angle BPO, and also they subtend equal angles at the center, that is angle AOP is equal to angle BOP. Please remember that. Now the common tangents. The tangents which are common to two or more circles is a common tangent, and there are different types of common tangents. We have got the direct common tangent called as DCT, and the transverse common tangent called as TCT. Now a common tangent which has circles on the same side is called as DCT. Now let us understand this. Now we have a circle C1 and circle C2, and the AB, this AB is the tangent, and since the centers of the circles lie on the same side of the tangent, it is called as the direct common tangent. Now a common tangent which has circles on either side is called as TCT. Now here we have circle C1 and circle C2. AB is the tangent. Now the center of circle C1 and circle C2 are on either side of the tangent, and therefore the tangent is called as a transverse common tangent. Congruent circles. Circles are congruent if they have the same radii. If you look at the circle C1 and circle C2, the radii are same, and therefore they are congruent circles. Concentric circles. The circles with the same center and different radii are called concentric circles. Now circle C1 and circle C2 have the same center O, but the radii are R1 and R2, and therefore they are concentric circles. Remember that. Now intersecting circles. Two circles that cut each other at two distinct points are called as intersecting circles. The circles have a common chord. Please understand this. Now we have circle C1 and C2 here, and they are intersecting at two distinct points, that is A and B. So therefore they are intersecting circles, and the intersecting circles have a common chord AB. Remember that. Now one more very important thing is the distance between the distance between the center of the circle C1 and the center of circle C2 is less than R1 plus R2. Remember that. So that is very important here. R1 plus R2 is the radii of the two circles. The distance between the centers of the circles is less than R1 plus R2. Please remember that. Now the touching circles. Now touching circles, two circles that touch each other at a point are called as touching circles. So now here the circle C1 and circle C2 are touching each other at point P, and since they are touching externally, they are called as externally touching circles. And here the two circles are touching at point P, but they are touching internally, and therefore they are called as internally touching circles. Now the distance between the centers of externally touching circles is R1 plus R2, whereas the distance between the centers of internally touching circles is R2 minus R1. So please remember, these are very important relations which you have to remember. Now the properties of chords. The length of chords increase. The length of chords increase as the distance of the chord from the center decrease. Now if you look here in this circle, AB is a chord, CD is a chord, but the length of the chord CD is greater than AB, and the distance of chord CD is less than what you call the distance of chord AB from the center. So therefore when the length of the chords increase, the distance from the center decrease. If chords are congruent, then their corresponding arcs are congruent. Now here we have the two chords AB and CD are equal chords, and the arc which they subtend, the arc is CQD and the arc is APB, and both are equal. Remember that. So two congruent what you call chords subtend congruent arcs. Congruent chords subtend equal central angles. If we have two chords AB and CD equal, then the angle AOB is equal to angle COD. That means both the chords subtend equal angles at the center. The perpendicular from the center of a circle to a chord bisects the chord. Now in the circle we have AB is a chord here. When I draw a perpendicular from the center to the chord, it bisects the chord. That is AC is equal to BC. Remember that. Now the line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. Now it's a very important property. The AB is a chord, M is the midpoint of AB, and O is the center of the circle. If I join OM, then OM is perpendicular to AB. Remember that. Okay, very important property, remember that. Now equal chords of a circle are equidistant from the center. It means if AB is a chord and CD is a chord, if the two chords are equal, then the distance ON and OM are equal, they are at equidistance. Therefore equal chords of a circle are equidistant from the center. Now again, one more important property, chords of a circle which are equidistant from the center are equal. Now if you have two chords AB and CD, if they are at equal distance, that is OM is equal to ON, then chord AB is equal to chord CD. All these properties of chords are can be learnt as theorems. We can prove all these properties, which will be doing it sometime later.